In part A of the subway train problem, we want to find the maximum speed that the train can hit going from subway A to subway B at an acceleration of 1.35 meters per second. Now in this equation, this is our station A, station B, the total distance is 614 meters. Now in order to find the maximum speed that it can obtain before it has to start slowing down again, we have to find the halfway point, because that's where it's going to be hitting its max speed before it has to start slowing down in order to come to a stop at the station. So we can set up a chart like this with event 0, 1, and 2. Event 1 being the halfway point and event 2 being station B. So the initial time is 0 seconds, initial x value is 0 meters, initial velocity is 0 meters per second. And from event 1 to event 2, station A to the halfway point, it's going to be accelerating at 1.35 meters per second squared. And at event 2, it's going to be going from the halfway point to station B. So it's going to be slowing down at a rate of 1.35 meters per second squared. So we put a negative sign there to represent that it's slowing down. Now, in order to solve for V1, what we want to do is use the formula VF squared equals VI squared plus 2 times the acceleration times the change in x, because we're given the values of the initial velocity, the acceleration, and the change in x. And this is for event 0 to event 1. So this is going to look like this. VF squared is equal to initial velocity squared, which is 0, so just 0, plus 2 times 1.35 times the change in the distance. So it's going from 0 to 307, so it's 307 meters. So that is going to give us VFF squared is equal to 829. And then we want to take the square root of both sides, and we are left with V of f, which is V of 1 on this, but for the sake of the equation, I'm just using V of f. It's equal to 28.8 meters per second. So our answer for right here, for part A, is 28.8 meters per second is the speed that the train can hit before it has to start slowing down to arrive at the next station. In part B, we're solving for the total time that the train travels between station A and station B. Now, when looking at the total time from event 0 to event 2, we're solving for t of 2, and we see that the acceleration from event 0 to event 1 is 1.35, from event 1 to event 2 is negative 1.35, so they cancel out, and that means that the acceleration is going to be 0. So that means that we can use the kinematic equation for constant acceleration. Now, when we're doing this, what we want to do first is solve for solve for t1 first, and then we're going to multiply that times 2, because it's going to be the same time to get from event 1 or event 0 to event 1 and event 1 to event 2. So the way that we want to set this up is x of f is equal to x of I plus 1/2 times the change, or times v of the initial velocity plus the final velocity from event 1 or event 0 to event 1 times t. Now we know that from event 0 to event 1, the final x value is 307, and the initial one is 0, so we had 307 equals 0 plus 1/2 times 0 plus 28.8, so 28.8 times t. So 1/2 times 28.8, 14.4, so 307 equals 14.4 t divided by 14.4 on both sides gives us 21.3 seconds equals t from event 0 to event 1. So we can go ahead and erase this question mark, put 21.3 seconds. And now to get the final, or the total time from event 0 to event 2, all we have to do is multiply this times 2 because the acceleration numbers are still the same. So that will give us 42.6 seconds equals t. So it means that it takes 42.6 seconds to get from station A to station B. For part C of the subway train problem, we want to find the maximum average speed of the subway if it adds 20 seconds in between each station before it starts moving. So right now we found in part B that it takes 42.6 seconds to get from station A to station B. Now if we're adding 20 seconds, that means all we have to do is 42.6 seconds plus 20 seconds equals 62.6 seconds. Now we're finding the average velocity, or the maximum average speed, which is velocity. So we're going to be solving for v, and the unit of velocity is meters per second squared. So that means that if initially it's taking 42.6 seconds to cross 614 meters, now it's going to be taking 62.6 seconds to cross 614 meters. So meters over seconds, 614 meters over 62.6 seconds is going to give us 9.84 meters per second. So the answer to part C is 9.84 meters per second if it adds an extra 20 seconds in between stations.